Time complexity often expressed using big O notation. Big O is a mathematical notation that describes the relationship between the running time and the input size. In a nutshell, the time required by the algorithm to solve a given problem is called time complexity, and big O notation illustrates how the algorithm's running time scales with the input size. Please note that big O notation provides an estimation rather than the exact running time, and it doesn't provide precise details about the actual running time. In a simpler term, it provides an upper bound or worst-case estimation on the growth rate of an algorithm's running time rather than an exact measure. Now let's wrap up with an example. Here we have some students and the problem is to find out who is Peter. In the first solution, we ask who is Peter. Regardless of the input size or the number of students, Peter will raise his hand. Therefore, the input size does not influence the time it takes to find out who Peter is. In this case, finding Peter in a classroom serves as a constant time operation, because regardless of the total number of students, you can identify Peter by directly asking, and the process is not dependent on the size of the input. In the next solution, we ask each student one by one to find out who Peter is. The time complexity is influenced by the input size, and the time required to find Peter increases proportionally with the number of students. Unlike the first solution, where asking directly for Peter's identity, this solution is now tied to the size of the input. Each additional student introduces an additional step in the process. We should investigate each student one by one to find out who Peter is. As is observed, Peter is now found in the 5th position among the students. Lastly, please take it into consideration that big O describes the upper bound or worst-case scenario of an algorithm's performance. In this example, even if Peter is found in the 5th position, big O considers the possibility of Peter being found in the last position. I hope you enjoyed learning, and thanks for watching this video.